right, so today we're going to go back over to simplifying algebraic expressions. We did that a little bit ago, but now that we know a little bit more about the distributive property, about the different parts of an expression, we're going to kind of go back through it again. So your learning target is, using what I know about expressions, I can rewrite expressions in simplest form. So the definition is of simplest form. Let's do that first. Simplest form is an algebraic expression will be in simplest form when there are no terms, no like terms, and no parentheses. And remember, like terms have the same variable to the same power, and parentheses means that we've solved everything inside. There's nothing left to do on the inside. So we've used the distributive property. All right, so the key concept here is, in order to write an expression in simplest form, we just have to use what we know. What we know about properties of operations, what we know about the distributive property to solve these types of problems. Okay, so let's do a few examples. Example 1 says, write the following expression in simplest form. We have 2x plus 5x. Okay, now what we see here is that these are like terms, right? And here's the really cool thing about like terms: when you're adding or subtracting them, all we have to do is, these are common, so we just have to add or subtract these numbers. So 2 plus 5 is 7. So in simplest form, 2x plus 5x is equal to 7x. We can just add those together and we get a 7x. That's it. Example 2, write the following expression in simplest form. 9m plus 4 minus 6m plus 10. So what I like to do when we're faced with these types of problem is rewrite the expression, but we're going to combine, we're going to bring the like terms next to each other. So we're going to start with 9m. Okay, got rid of that one. We still have 6m over here, so we're going to minus 6m. Okay. And then we have 10 and 4. So plus 10 plus 4. And that takes care of all of the expressions that we had, or all of the terms that we had in this expression. And I went ahead and I crossed them off, because even though I could probably organize these in my head without crossing them off, we face a lot of problems that are a little bit larger than these. And so it's a good idea just to make sure that we don't add them too many times, or we forget one, to write one down and then cross it off. So we have 9m minus 6m plus 10 plus 4. So now we can combine those like terms. 9m minus 6m, that would just be 3m. Plus 10 plus 4 is 14. So there is no more like terms in this expression here, and there's no parentheses, so this is written in simplest form. All right, last example now. The cost of a jacket, J, after a 15% markup can be represented by the expression J plus 0.15J. Simplify the expression, then determine the total cost of the jacket after the markup if the original price was $50. Okay, so here's the cool thing. Is we're going to take, we did markup a long time ago. We're going to take what we know about expressions now, and the distributive property and all that, and we're going to combine them to be able to do something amazing. So we have this expression here. I'm going to rewrite it. I have J plus 0.15J. Okay, and so I'm going to take a J away from both of these. So essentially what I'm making is a distributive property. But remember, this is really a 1J. So we cannot forget that this is 1J plus 0.15J. So if we pull out a J, we're left with just 1 plus 0.15. Okay, and so that's why it's really important to remember this 1 in front of the J, because you don't want to pull out the J and just be left with 0.15. Then you would have an incorrect answer. Okay, so now that we have done this, we can add these two together in here. 1 plus 0.15 is 1.15, and I'm just going to move the J back over to this other side, So J. So really, we could have just added right here 1 plus 1.15 because they're like terms, so it would have been 1.15J. But I really did want to show you that what we're doing is we're really pulling out the J, and then we have what's inside. So we're left with 1.15J. So now the second part of the problem, let me scoot it up a little bit. Second part of the problem says, then determine the total cost of the jacket after the markup if the original price was $50. Okay, and remember, J is the cost of the jacket. That's the original price. So we're going to take 1.15 and we're going to multiply that by 50. Let me box this up here. We know we've done that one. So first round is just going to be 0. So the second round I'm starting with the 0. 5 times 5 is 25. 5 times 1 is 5 plus the 2 is 7, and 5 times 1 is 5. And so we have to move the decimal point over twice. We get $57.50. How cool is that? That is what we're doing today. That's all you're just simplifying expressions based on what we know about the properties of operations, the distributive property, and we're getting rid of those like terms, making it easier to look at. Perfect. Enjoy. Happiness.